everyone. In this lecture, we're going to be talking about hypergeometric distributions. Now, that's quite a lot to say. I'm going to spell that out for you. Hypergeometric distributions. Now, most people, when they hear the phrase hyper in front of a math term, it typically means we're just going to take that concept and make it more difficult to understand. Or we're going to make it a little bit more complex, I should say. And yes, that's exactly what we're going to do. We're going to take geometric distributions, which we talked about in the last lecture, and we're going to bring it up to the next level. The idea is, with hypergeometric experiments, we have two groups. Now, these two groups are separate from each other. Maybe we have a group of men and women. Let's say we have, like, for example, 11 men and 13 women. And the idea is we're going to pick some people from each group. Now, we might pick men, we might pick women. In this case, we are more likely to pick women than men because we have 13 women. And so the idea is we're going to pick a certain number of people. We're going to say n equals 10, meaning we're going to pick 10 people total. Now, we're going to define one of these groups to be a quote-unquote success. So let's say this group is a success, meaning that we consider pulling a woman from the women's group a success. And what we're interested in is how many successes are we going to get? And that is going to be the variable that we're going to be talking about. So X is going to represent the number of successes. Now think about it. We could get 0 women. If we pick 10 people, we could pick 10 of the 11 men. Now keep in mind, with hypergeometric distributions, when we select people or select anything from our groups, we are not replacing these groups. So if we have, for example, marbles and pens, when we start taking things from the two groups, we are not replacing them. So for example, if we pull like 4 women right off the bat, then the chances are we're actually going to get more likely a male the next choice, because there would be more men at that point. And so the idea is the trials are not independent of each other. And so for that reason, they're not quite Bernoulli trials. So X is going to be the number of successes. So we could get 0 women, we could get 1 woman, we could get 10 women. We're more likely going to get about 6 women. But these are really, really interesting distributions when we talk about them. Now, that being said, let me give you guys a formal definition of hypergeometric experiments. There are 5 characteristics of a hypergeometric experiment. Number 1, you have to take samples from 2 groups. So marbles and pens, men and women, or Republicans and Democrats, or something. You have 2 groups, and you're going to draw a sample from both groups. You are concerned with a specific group of interest called the first group. Now, we're just going to call that the success group, if you will. You sample without replacement from the combined groups. For example, you want to choose a softball team from a combined group of 11 men and 13 women. The team consists of 10 players. That's exactly what we were talking about. Each pick is not independent, since sampling is without replacement. In the softball example, the probability of picking a woman first is 13/24, because there's 13 women, 24 total men and women. The probability of picking a man second is 11/23. I'm not even going to try that one. If a woman was picked first, so keep in mind that's presupposing the woman was picked first. It is 10/23 if a man was picked first. The probability of the second pick depends on what happened in the first pick. And number 5, you are not dealing with Bernoulli trials, which you talked about in the last lecture. The outcomes of a hypergeometric experiment fit a hypergeometric probability distribution. The random variable X is the number of items from the group of interest. So in this case, X cannot be, with the softball example, X cannot be 11 because we're pulling 10 members. We can't get 11 women with 10. It's also a discrete distribution because we can't get 1.5 women. We can only get 0, 1, 2, 3, all the way up to 10 in that specific case. Anyways, I hope this makes sense. Thank you guys so much, and I'll see you in the next lecture.